Okay, very good. Then let's officially start with this webinar. So survey map, how to create a survey map in 3Dsurvey. Probably all you who already use 3Dsurvey know that 3Dsurvey is much more than just photogrammetry software. It's kind of device integrator, so you can combine different devices together. And beside this, you can also pretty easily extract out data which one you need for your end results. And in this case, we are going to talk how to use our CAD tools, which are integrated in a 3Dsurvey to extract out survey lines, survey points, how to attach the cadastral measurements and all this stuff together. So super interesting topic. Today with you, Matthias Zupan, our quality assessment manager, who's working with software intensively and know all tricks and tips. And me as a product manager, Marko Meseric, so also with the 3Dsurvey from the very beginning. By profession, I'm also surveyor, so more or less we know what you need on a field and we are implementing those features in the software. And here is our guidelines for today's webinar. What we are going to do, we have a nice, exciting, small project which was captured with the DJI Mavic Mini 2 drone, the small one which weighs just 250 grams, okay? And then we extract out contour lines. We go and extract CAD lines and points in a different layers like objects or buildings. Then we have roads, fences, roof, manholes, height points and all this stuff. So we will show you when we are extracting all these details, all the tips and tricks which you can use during the data extraction. And then at the end, we will also import cadastral boundaries in the 3Dsurvey, a new super powerful feature. So 2D DXF to mesh to 3D mesh transform tool. So you will see this at the end. And nevertheless, how can you export out results or create PDF from everything what you created then? We prepared a nice video for better experience that is not going to break something or anything like that. So the presentation should be smoother. During the video, please write your questions in the chat box as Mattia already mentioned it, and we are able to answer them during the end of the webinar. The total time will be approximately 1 hour of everything. And before we continue, I think Mattia is ready with a short survey.
Yeah, we got a few polls for you. So as Marco mentioned, you see we have quite a lot of planned for you today. We'll do a lot of stuff. So let's not waste any more time and break the ice with the first classic question. Are you already a 3Dsurvey user? So only 3 options, either yes, not yet, or are you even closer to the yes than a no. So you're thinking about buying the software. Perhaps you're trying out the trial and doing your pilot projects. So let us know where you stand.
Okay.
Almost 60% of you already voted. Let's get some more votes in.
Okay, the questions are not too hard, don't worry. And there is no wrong answer. There is no wrong answer, okay?
Don't be afraid. But we can see you slacking. Don't sleep on the webinar. Okay, I think we got enough answers. So let's close the first poll. And here are the results. So majority of you are already 3Dsurvey users, 72%, and almost 20% not yet. And in between, we have 8% of you who are thinking about buying the software. That's great. Should we jump to the next one?
Let's do it. Perfect.
Okay, now a bit more technical. So this one was easy. Now you'll have to think about. What is your surveying setup? So what's your hardware? What's your equipment? How do you do your job right now at the moment? So do you have GNSS and total station, GNSS and a drone, terrestrial laser scanner, or a SLAM device? Or perhaps you have all of the above and you just don't know how to utilize it all. A hint, you can utilize it all in 3Dsurvey, so don't worry about that.
Okay, interesting one. Let's see what kind of answer do we get, just to have a clearer idea also for the future.
Okay. So we have almost 80% of votes in. Last chance to cast your vote.
Okay,
3, 2,
interesting
1.
answers. Interesting answers. Very good.
And here are the results. Marco, what do you think?
Yeah, I think it's the right topic for you guys. So very good. Happy to see that. So GNSS plus drone, very good combination. We see the total station is going a bit down, maybe more, yes, for other projects, not for survey map extraction. But there is also few of you that are using all these technologies. So super
That's
tech,
very
high tech
exciting.
people. So very exciting.
Yeah.
Okay,
Great.
fine.
Okay, I'll close this question down. And just one more question right now. So what is your industry? So maybe you are a professional surveyor, or maybe you work in different primary industry and you are surveyor in construction or mining, geology. Maybe you work in architecture or something completely different. Let us know in the comment if that's your case.
Okay.
So we sort of expected that most of you will be surveyors today, or yeah, surveyors working in different field, but still responsible for doing all the field measurements and vectorization, cadastral data and stuff like that. Okay, thank you for your answers. Closing down in 3, 2, 1. Here are your results. As expected, most of you are working in surveying. A lot of you also from construction, some of you mining, geology, no architects today, so maybe we can make some jokes on architects.
Let's do that.
And and some other non-covered in this survey because we only have 5 answers available. Okay, nice to get to
Very
know
good.
you a bit. Okay, Marco, are we ready to continue?
I
I
think
give
we
the word
are.
back to you.
Yeah, very good. Thank you. So this was a short warm-up to get even more feeling from the audience. And now I think we are ready for the complete workflow to show you how it goes. I'm sure you know most of the tricks already, but definitely you'll probably learn something new. Right in front of you is the complete workflow. What are you able to extract out from the photogrammetry data with the help of 3Dsurvey software? Again, if there are some questions, write them during the video you're going to watch, that you don't forget something. We will try to answer them at the end of this presentation. The video is about 40 minutes long or something like that, but super interesting. So let me just start this one to play, and yes, write your comments and questions. I will try to answer them also during the video, so don't hesitate to write them. And yes, let's start with this session. Okay, here is our project. We would like to create a survey map from this data. And here we have 504 images. These were taken with a small DJI Mavic Mini 2 drone, so drone which weight less than 250 grams, we need to fly it manually because the automatic flying is not supported by this drone. But nevertheless, we were able to get images which are good enough to calculate out 3D model later on. Because drone does not have a RTK antenna, we use 8 ground control points to do the orientation of the model. We placed 3Dsurvey ground control point targets, which help us with the orientation because it's almost fully automatically. And then based on these images, we first calculate the bundle adjustment, which gave us the basic model. Then we go to orientation with ground control points. We did the orientation, survey grade accuracy, 8 ground control points, independent measurements, and so on. And the third step was reconstruction. And with the reconstruction, we get that kind of point cloud. Definitely, it's not the best one. There is some noise in point cloud because of the low power camera. So if you would have a more better state-of-the-art drone, the results would be even better. But again, we get good enough data for survey data extraction. Next step from the point cloud, it was a full 3D mesh, which was calculated from this point cloud and images. It's a nice textured 3D model. Again, we can see some artifacts close to the roof edges and on areas where we didn't cover areas with the images so well. And next result, or the photo, because it was calculated from full 3D mesh, it's also a true orthophoto, so it means the building roofs are on the right position, also all fences, traffic lights, or anything what's popping out from the terrain, it's on the right position. Beside the true orthophoto, we also calculate the X-ray orthophoto, specific 3D survey feature. The X-ray help us to define building corners, and we can here nicely see the rough estimation where the walls are going, so we can see actually through the roof, and it's a nice option to double check the CAD extraction data from images, point cloud, or mesh at the end. So if I turn on just the X-ray orthophoto, you see it looks like that. So the building roof edges are nicely extracted, the walls and corners are extracted, some fences are nicely visible, and so on. Okay, let's go back to point cloud, and what I would like to start with the process of preparing my data for survey map generation in 3Dsurvey is first we need to have a digital terrain model so that we are able to calculate contour lines. So what we need to do, first, we need to classify our point cloud with the classification wizard. So I just click on the classification button. The classification wizard pops up. Here are actually classification parameters which are good enough for 95% of examples. So I will just confirm them with next. And in the second step, I need to show terrain point with my mouse cursor when I'm 100% sure that this is terrain. In usually case, a single click is good enough, but because this is a super tricky project, super tricky area where we have a lot of buildings, a lot of vegetations close to the buildings, a lot of natural fences, I need to spend a bit more time and help the software to define my terrain areas. So I will just click few more times on the areas where I'm 100% sure that this is actually terrain. Okay, so I click approximately, let's say 10 to 15 times. Also here maybe. Then we have covered the backside of our terrain and one more here. And let's say I'm ready now for the next step. I click the next click and you see now I get immediately much more terrain points detected automatically. Definitely I would like to add also this area here and maybe also a spot here. Okay, quick trick. If you click here calculate on the left side, you're actually repeating the classification process again. And I would say I'm quite satisfied now with this result. So I will click on finish to finish my classification. Of course, I could spend even more time to add those parts which are super hidden and maybe also here. But for first, I think for the contour lines, which is kind of a terrain approximation, this should be good enough. Okay, if I now deselect never classified and unassigned class, which I got with the classification, and I click on the clear to get my natural color back, I can see my terrain classification here really nicely. Okay, what could be maybe better? I still have a bit of the house, which I would love to remove it or put it to another class. So how I will do it, I will go to select and just with a quick selection tool, I will select point cloud and then just right mouse click on unassigned, set this class to selected points. So in these points, I can improve my classification results. Let's do also here for this part of facade, like that. Right mouse click, set this class to selected points. And now I just remove selected points from the ground class to the unassigned class in this way. Okay, let's say this is more or less okay. Here we have one more steep terrain. Let's also improve this one. As mentioned, classification for this kind of project here, it's super tricky. Let's say in most cases, it's much easier because the terrain is not so colorful. Okay, cool. Here we have now ground points, and next step towards the contour lines, it's that we go and calculate mesh. I will click on mesh, and for the contour lines, I will use the first approach. So calculate new regular grid mesh, DSM, or no, because we don't have points from the objects and vegetation, everything else. It's actually a DTM. Okay. Calculate new grid cell size 0.5 meter. It's good enough. Smoothing cell 0. I could go maybe to 1 cell because we have a mini drone with a lot of noise and there are not some triangles which are popping up from the surface. I will increase the smoothing to 1 cell. Everything else is fine. So whole filling mode, in this case, I will take all because I would like to have a nice square area and contours on the complete side. Let's click on calculate, and this is calculated in a second. Now we have here a regular grid and full 3D mesh. Let's turn off the full 3D mesh. And if we inspect those areas, I can make a hide map with a shading. We can see already here the road is nicely visible. Probably here is our building, the neighbor building, and so on. And up here again we have another road. Okay. If I turn triangles on, you see this is kind of a regular grid mesh, and this is the perfect data type if you would like to calculate contours. So next step, I will go here in the right lower corner, we have calculate contour lines. Equidistance, usually for survey map, we calculate contour lines with the equidistance of 1 meter. Here, simplification by default on to smooth out the contour lines and click on calculate. And if I turn off the regular grid mesh, here we can immediately see our contour lines. I think they see gorgeous out. If I move between the tabs here on contour line, I can see them again in a 3D. And if I would like to have the text for the contour lines, which is the height of the contour lines, I can turn it on with show height. And you see the contour lines are designed in surveying standards. So every fifth contour lines is a main contour lines, and then you have semi-contour lines in between. Okay, even if you export them as a DXF, they will be defined in the correct layer with the main and sub-main contour lines and with the right colors. So again, with the mesh, this looks like so. So we see it's fitting nicely also to the mesh. Okay, let's go back now to contour lines. We have them ready. I will just turn them for now off because I would like to continue with my data extraction. We are done with our first step. Now we are already ready to go for the CAD elements. Okay. I will turn off now the regular grid mesh and turn on the full 3D mesh. I can use the texture. This shows me the most out of it. Now I can decide it if I would like to extract data from mesh data from full 3D mesh or from point cloud data. Let me also turn all the unassigned and never classified classes back to have all the points and click on clear to lose the selection. And maybe for this case, in this project, I will decide that I will extract data with the help of point cloud points because as already mentioned, the camera from Mavic Mini 2, it's not so powerful, creates quite a lot of noise also at the end, and then we have that kind of balloons close to the roofs and edges and so on. So I will turn also the full 3D mesh off, turn just the point cloud on, and move to the CAD tab. And now I see just point cloud here. If I would also turn on the full 3D mesh and I move to CAD, you see, I see point cloud and mesh together. Okay, so just go on, decide it what you would like to see. So point cloud on, mesh, I will turn it off. And back to CAD, and now I'm prepared for extraction data out. Okay, cool. So here we have a kind of complete layer system, CAD engine inside. So we can create new layer, we can change names, we can set colors, thickness, make the layer active, and so on. But my suggestion is as follows. If you are always extracting out, let's say, same layers from photogrammetry data for survey map generation, there is a good option to prepare your first time, let's say, kind of a layer system. So let's say buildings, color, let's say salmon, thickness 3, next layer, road, color blue, same thickness 3, and so on, and just save this data as a CAD. So you're saving a DXF file with the layers, but no data is in there. And then what you can do I will now go and delete all layers. And what can you then, when you start with extraction, you go to data, load CAD, and you go and import predefined layers actually here. Okay, the layer system is now ready, preset. I will just activate my first layer, building. I would like to extract first the building footprint out, so double mouse click on the first icon to make it activate. You can see that the name is now bold. And now I can go and select my draw line tool. I could use point on vertex to create also points where I click with my mouse, but for this case I will use without this one. And if I just use now the left mouse click, like that, I'm extracting out data for my building. If I turn on also option drawing on images, I can double check the positions and so on, and also correct those positions on images, and then this is in real time recalculated also here in 3D. But now I will use my backspace just to delete points I already created, and I would like to show you a new approach where we are able to extract building footprint with the help of defined plane feature. So because we would usually like to have the complete building footprint is on the same height, on the same level, we developed this feature calling plane option. And how it goes, if I click define plane, I can select my point on which I would like to create a horizontal plane. Because the building footprint usually should be by surveying standards on elevation when the main entry of the building is, I would place my main point here, and when I click a single point I get a perfect horizontal plane for the complete area. If I would use more points, actually, the plane would perfectly fit to those points. But if for the perfect horizontal plane, single point, it's perfect one, just click confirm point, and now everything what I'm extracting on my point cloud, it will just vertically snaps to the this plane I just defined it. Okay, and this is very useful thing to extracting out. And I need to decide it. I would like to go with the building facade or with this lower part of the building facade, which is a bit smaller actually. And I will take this one because I will use also later on this data for cadastral boundaries and so on. And I need to have where the building is going into the terrain. So what can I do now? I don't need to snap fully on the lowest part. I can go a bit up because the height will be always transformed to the plane actually. Okay, and let's say this is my building corner. Let me make from different perspective a bit that I can see it here also in a 3D, and also even if I have a plane option, I can correct on the images. And let's go to find my second corner. So again, I'm here, double check again on my images. It's perfect, aligned as we can see. And now, because buildings are usually perpendicular, and with the plane option, we open also this opportunity. So if you click here, Object UCS, or if you click the keyboard shortcut F8, check out this net of the plane will rotate and will be aligned fully with your line you just created. So if I press F8 now, you see now the white lines from the plane are now aligned with my line which I just finished. And now my snapper is pushed to the perfect perpendicular position. And in this case, I can go and super efficiently extract out the data with the perpendicular option. And let's say this is my next corner. Okay, then somewhere here. Even if I cannot get the right position of the end corner here, I can go and define my end of the line actually with snapping on the building facade which is next in a row, so like this one. If I click here, I finish my connection perfectly. And even more, if my building is not perfect, I can snap on my last point like so. If I'm sure that my building is perfect, I will click one backspace to delete my last selection. And now I will try to activate my snapper by moving to the end point of this line. And now I get actually the perfect suggestion where this line should end, and just click it like so. And now I perfectly add it with this one here. And in this workflow, I actually generated the perfect building footprint. Let's go now and also add here the stairs. Okay, like so. I'm still in perpendicular snapper mode. Here is a lot of data probably missing. I will go to point cloud and make these points a bit bigger and back to CAD so you can switch. You can see I'm always switching actually from point cloud to CAD tab, not a problem. And I will try to find where the end of the stairs are actually. And I think it ends somewhere here and finish on my line. So only this way I extract out the stairs and building footprint actually. Back to the point cloud, smaller the points, and that's it. Okay, cool, cool. Very good. Let's go to the next step of this building. I would like to extract out the roof. Again, cat, activate my, roof layer, go to draw line tool. Again, I will do with the help of plane, but I define the plane based on 3 points and I will confirm plane because when I'm using the plane option, I can nicely use also perpendicular options. So what I need to do, I need to extract my first line like that, improve it on a point, then again F8 button to align it, and now I can draw like that, so I can see even clearly where it is. And again, if I like, I go and activate my snapper, the last one, and then I get suggestions with the green line. Okay, it should end something here and like that. And you see, and this is a perfect match for my roof. And let me go and select another plane. So I'll click on reset, define new plane, the other side of the roof, 3 points. I could place more if I would like to, so it's always adjusting to the number of points I created. Confirm plane. No, I will go and draw first my main line. I will snap already to existing on, F8, and again, extracting the roof data super accurately like that. Activating where I would like to finish with my polygon. The green, you see the green line gives me the suggestion when it should end to finish exactly at the end, and this is my roof. Reset plane, and I already extracted the building footprint, the stairs which were super hidden actually, and my roof in a 3D actually. Okay, cool. Next step I would like to extract out is road. So I will go and activate my road layer, take a draw line tool. Here I'm going to work actually without defining the plane feature. I will just help me here with actually with drawing drawing on image support. Here we have a curve which was height in a 2 centimeters or something like that. Okay. Here we have kind of a standard curve. If I go, you see how this looks like actually. Okay. And we have another trick here which can help you. So let me maybe switch here from point cloud rather to mesh and back to CAD just to see how mesh looks like in this example. You see, so I think I didn't select this last point perfectly. It should be probably more like that. Okay, so I correct the position. And now we are moving to the curve, and we see the curve is also not perfectly extracted. But let me show you another trick which is available in 3.1 version. So take the draw line tool, snap to the last vertex, move to your next point, and because I would like to see how far I'm moving, because I don't want to have every 1 meter a break line or something like that, so I will move it for 5 meter or 10 meter. Here you can see the distance is kind of a help tool. And now if I place my point exactly here, the horizontal position of a curve will be okay, but the vertical position, so the height of this line is not going to be perfectly. Will definitely be 5 to 7 centimeters off because we cannot create a perfect curve with such a small drone. And we would need to map really detailedly if we would like to have a perfect curve, but we have a trick here. If you create a quick plane with keyboard shortcut Q, you can actually freeze the height and you can transform this height to the best horizontal position and click it. And in this phase, you're actually transforming the heights where you are 100% sure that the height is okay, and you move this height to the right position like so. Okay, and now if we check the result, you see it's a perfect fit, perfect extracted curve out from the data. Okay, let's continuously connect also here. Here again, it's a lower curve. Okay, because of the water floodness, they actually added some material here. So I will step here, and again, I will help move with my Q button to freeze the height 20 centimeters away from the curve, and then transform this height to the exact position. And in this way, we actually super efficiently extract out 3D curve in highest accuracy possible. Okay, so here again we don't have curves anymore, so let me go closer. Yes. Okay, so we can just continue with connecting the road like that. Okay, we finished with the one side. Let's go back to another side, see how it goes. Let's start with the same position here. Okay, what I need to decide it here, where actually the road is. Let's take it, yes, the widest one. Okay, cool. Let me just double check if I need to transfer my height. Yes, the mesh also is here, not the perfect. So first one, double check on images if everything is fine. That's cool. Again here, very good. Continuously on this side. Like so. Okay, then here we have kind of vegetation. Okay, you see, I made a big mistake here. If I rotate this in a 3D, let's click a backspace and use the Q option to transfer the height on the right position. And now this is much better. Okay, very good. Okay, let me find the good connection point again here. And here we can see clearly again our curve. Okay, very good. So this one is actually nicely defined, so I could directly connect out to it. Otherwise, I would use it again, the Q, quick plane option, and extract out the data. So here we have some vegetation. I'm more sure if I do it like that. Okay, and move it to the corner. Very good. So I finish my additional line here. Okay. Okay, let's go and take fences. Okay, we finished a lot of line works already. So next step I will vectorize also all the neighborhood buildings. So building footprints and the roofs, the main roofs one. Then the next step are manholes. Okay, so you can see it's going super quickly, even if you speed up the video a bit. But it's great that you get an idea what kind of work you need to do it. So, but it's if you imagine to record and capture all this on a field, it would take quite a lot of time, definitely. So, but with the help of drone from this area perspective, we can capture super hidden details here. So from my experience measuring this kind of area on a field with a traditional total station and
Okay,
GNSS
let's
device would
create
take
the
quite a lot of
roof
time.
boundary for the last buildings here. More interesting one because it's not square. So what we can do here, again, we start on the top of the roof. So like that. Very good. F8 for perpendicular. Fully down to the end of the roof. Also here to the right corner. No, we don't have a perpendicular option here. What we can do, not to lose the defined perpendicular snapper, Alt button eliminates just a temporary perpendicular mode. So press and hold the Alt button on keyboard and go for your right position, like here. Release the Alt button and you're back to the perpendicular mode. Activate the final snapper and that's it. Another trick, so with the Alt button to solve situations like that. Okay, and again reset plane, confirm, define plane, another one, confirm, main line, F8, activate the last snapper, check where we are, check the accuracy, that's it. Reset view and last building is finished. I'm not going to extract the building footprint for this building. It's just not the best visible. The data acquisition was here so I could maybe just show a rough estimation how the building wall is running like that, but I couldn't connect this building because it was not mapped here with camera, so we can see the main focus was our building. So next time, if I would do the survey map data acquisition for the survey map, uh, I would do it for the broader area, so not for just for the main building, because here in this case, our host was nicely mapped. Mainly the circles were flying around this building, and other buildings are not here actually nicely covered from the back sides and all this kind of stuff. Okay, we mainly finish with the line work and I think we are more or less ready to do at some points for the manholes, water, power line and everything like that. So I have just a single layer here created. I could have more, but I will do this in a single layer, in a manholes, etc. And just use here the point code in addition to write what I'm marking. And I think this is actually electricity. So I will just grab a point, go to the center of the manhole and place a point. And with the help of code, I know what kind of manhole this is it actually. And in this way, I go and extract all data from my drone results. So it's going like that. 3, and here is the last one. Okay, this one is a bit different. I think it's a water. Let's place it. Okay, so also here, and this is actually a water shut off. Let's place it here. Let's check if there's another one. Yes, here it is, another one. Water shut off, and here another one. And also here one. Okay, then we have a drain here, like that. And this is optics. Okay, like so. Okay, another electricity. Okay, all good. All good here. All good. Very good. Up here. Again, electricity. Electricity. Okay. This is actually a sewage. Sewage. And water shut off. Okay, let's check on our main area if there is kind of something hidden. Ground control points, no, no. Ah, here we have something. So first we have a drain, then we have a sewage. Okay, cool. Ah, here on building facade also something. I think it's telephone box, like that. Anything else? I think we nicely covered. Cool. Ah, we have also traffic lights here. So let me also place some point for the traffic lights. I just predefined them here. I could also import this stuff from the text file. So we have a tutorial about this one, how to do it. Again, I will use with the Q button plane and move it to the center of the pole like that. And where is the next one? Here. So Q to fix the height and move to the center of the plane. Okay, cool. So 2 traffic lights here. Up here is another one, but yeah. Let's leave this one. Okay, cool. I think we find most of the manholes, power lines, electricity, anything like that. Next thing I would like to place are few height points. So just to describe the terrain also with the height points. In this way, I will remove the code from the point, and also name of the point is not needed. So I can actually just go and place points. For example, where I would also classically, let's say, measure some points to define the height. Take care that you don't snap on the, I don't know, fence, on a vegetation or something like that. And in this way, you can nicely extract out. If you like to check where you place this point, you need first to place it and then click again to see on the image where you actually place it. Okay, just for your idea. Then sometimes it's great to have also some height points also on the lines we created here. So I could place a point and I will just use a snapper or nothing else but on vertices. So no, I can't snap on a road or anything like that. So I just snap where the vertices were placed, like so. So nice high definition point, which are also super important. Okay. Also here close to the entry. We can see the entry height, the same here. Like that. Very good. I could go and vectorize also here the inner part again with the plane and perpendicular. But yes, just for the webinar to get the idea how it goes, I think it's more or less okay. Okay. Very good. Very, very good. Okay, ground control point. I could vectorize all these small details and also here the vegetable areas and so on. So it goes actually the same way. But even with that, we get a good idea what's on the field and nice information for survey map. So just to repeat it, let me turn on also contours and go back to CAD to see what we have it here. So we have contour lines, we have buildings or objects, we extracted the road, we extracted the roof edges, fences, manholes, height points. So most interesting points we need for the survey map. Let me go out and turn off the 3D model just to see how this is. I think the points are maybe a bit too big, so what I will select a single point, click on this arrow down, select similar on same, let's say select similar, and in this I could set the font size to 10 to smaller them, like so. It's even better visible now. Okay, very good. This is it. So we extracted most of the thing. Next step is importing the cadastral boundaries. And yes, let me show you how this goes. Okay, every 10 minutes I will just save this project, okay, just to back up everything in any case, because you know, CAD extraction is manual work and we don't want to lose something. Okay, so here we have our extracted data now. Let's go and import downloaded cadastral from our national database, and we save them in a DXF file. So I will go just again data, load CAD, and here is our cadastre or boundary lines, because actually it's on 0, 0 level. This is everything here, down there. And we get few additional layers here, so some points we don't need it. Let me just spend a few more minutes. Okay. Oh, this is okay, this is fine. This is fine. What are those points actually? Points are default layer. Okay, very good. Okay, so this is what we needed. We can change here the colors a bit to the colors we are used to it. So I will stop, okay, I'll make this one stronger a bit, like so. And if you see this now top down and ortho, you can see it like so. With a mesh on, we can now also see the boundaries exactly where they are actually running. We still cannot rotate it because I use the top down and ortho. If we go in a 3D mode, so it's like that. And here we have another hidden feature actually. If I go to mesh, and I'm not going to have a full 3D mesh, I would like to use the regular grid mesh. Okay, and go to CAD. Let me first turn off what I did, my extraction, so that I can just have the cadastral boundaries here, and I can go to mesh, right mouse click, and I can use the project CAD to mesh feature, and the ones who are selected, I will project them on the lowest points. I use the regular grid mesh where I don't have the 3D model for the buildings because the cadastral boundary usually goes on digital terrain model, and just click the project, and as you can see it, now this nicely fit to my 3D also. And now if I go and turn on the 3D mesh and go back to CAD and turn on all my layers I extracted, like that. Okay, default off. Everything it's nicely in 3D. Okay, maybe a bit of confusion because we have extracted boundaries, so extracted footprint from the buildings, and we have actually extracted CAD data and so on, but this is now all together like it should be. Let's check this in an ortho view and maybe X-ray on. You see how nicely I extract building footprints out? Just to double check the accuracy. Now those close polygon areas are a bit annoying. If I will open them, I will see, but okay, if I zoom in, you see, okay, here we have a misalignment, maybe 1 centimeter, 2 centimeter, because the height of this line is 1 centimeter, but here fit this perfectly. Also the roof, very nicely, all fit. So we can really quickly and accurately check this X-ray with the lines we extracted out. Okay, very nice. Even if I turn on the true orthophoto, it looks like that. Okay, let's move back to our CAD, to my main tab for this one. So you can see we extracted a lot of data out of it, even with contour lines. And now we're approaching to end of this webinar. I would just like to show you how to save all those results or outcomes to specific file format, okay? And first, I will show you if you would like actually to export all this data to third-party softwares, what you can do. And if we go step by step, first the contour lines, what you can do, you can go export DXF, you can export them in 2D or 3D, contours, save, and that's it. And you have a DXF file which you can open in any third-party CAD software like AutoCAD, Brisket, anything like that. Okay, this is ready to use. Then the next thing, if we go to CAD tab, we are able to export all these layers you have here on the right side as a data, save CAD as, survey map in 3Dsurvey. Let's go to result in the DXF again, save. Once again, you can check which one layers you would like to export. The ones which are active in 3Dsurvey will be also saved in a DXF, and just double click and you can open it in a third-party CAD software. Okay, couple of seconds. Okay, here we see, and everything is nicely done. Point name, point height, and point code. So as it should be actually. Okay, okay, let's turn this one down. Then the next thing you can export from here, it's of course the orthophoto. Let me just maybe turn off the CAD data. So one option is right click on orthophoto, save as, select the preferable file format. So for most CAD software, the TIFF is the best one. Otherwise, JPEG or PNG. But yes, as already mentioned, the TIFF format is the most standard one. And just save it. You get the best possible resolution, the ones which was calculated, and click on save. Okay, very good. So this is how to save CAD data, how to save control lines, and how to save actually the orthophoto for third-party softwares. And last but not least, so in the true orthophoto, there is also geolocation file. Okay, so the orthophoto will be shown on the right location and with the right scale. And okay, last but not least, you're also able to export actually all these results with our export option, export as a PDF. Okay, so you can define the size of your paper, landscape or portrait, also survey map in 3Dsurvey, some kind of title up there, you have a scale here, and you can actually zoom it to your preferable area and click on finish. Because I have here all the close polygons which I extracted, I have also colored polygons. If I would open them, I would have just a line. And this actually looks like so. Okay, cool. This was all from how to extract data for survey map. Let's go live now.
Okay, we're back.
We are back. Okay, pretty intense video, huh? With a lot of tricks, but congratulations, most of you stayed the complete time. So very good. Hopefully it was interesting for you. Me and Mattia, we answer your questions in parallel. So if there are more, please feel free to ask us. We have still 5 minutes or something like that. The most, maybe the most common question was with this quick plane, Mattia, huh?
Yeah.
So I could maybe demonstrate this one again. So let me go and try to extract the same curve again here. So I will make my road active. Then first what I need to do, I need to go to draw line tool. So to make it active, here are the snappers. If I'm snapping on mesh, the triangle is important. If I'm snapping to point cloud, the points need to be added here. And then the quick plane, you don't need to click this define plane, you just move with mouse cursor on a point of elevation you would like to have it. So not here, because 2-3 centimeters are probably off. So I suggest something like that. And then press and hold the Q button on keyboard, okay? As long as you hold the Q button, the plane will be visible here. And when you're holding the plane, move your mouse with your right mouse, right hand to the exact position you would like to place a point. Left mouse click, you start drawing. Now release a plane with a Q. And again, Q, hold the Q, press another vertex, release. So train it out. It's not that difficult, okay? And nevertheless, in the webinar, in the tutorials which Mattia recorded, there is once again, everything nice explained, okay?
You can search for this tutorial in our YouTube channel. It's called Precision Drawing in 3Dsurvey. We have also there this example and a few others.
Okay, very good. Mattia, can you share also the shortcut list? This was another question. So where do we have them? Do you remember?
It's on our website in the downloads section. I also posted the link, so you should be able to find it.
Okay,
in resources.
So let me go like that. Resources, downloads.
Yeah, and now all the way down.
Scroll down.
Here. So like
list
manuals
of shortcuts. Okay,
yes.
Here we have. You can see there is number of shortcuts already available. Okay, so check it out. Everything speeds up the process. Okay. Okay, good question. One more. So Mattia asked me before the webinar this, if I explain somewhere. So the question is how to generate label electricity sewage drain. Very good. Okay, let me go back to my project. So how this works? When you are in point drawing tool, so you have point code here. If you click this arrow down, you start with the empty one. So let me go how it goes. I will clear all now. It starts like so. So you just write it here, drain, and after you place a single point, this is going to be saved in the history, okay? So if I go now, electricity,
and confirm.
Sorry, electricity or something like that, place a point. No, this is already here, you see, electricity, where the drain goes? I don't know, let's go again with drain. Okay, now it's here, okay, and those are adding, so we remember our selection which you did. So if you made something wrong, you can delete it with red cross here or clear all, or you import this in a text file, just a simple notepad text file and one after another, and you can import it inside if you like. But you do this once and it's remembered for all next time, okay? Cool, Mattia, do we have anything else?
Yeah, there's a question from Maximilian, and it's about the final export you did in the PDF, where all the closed lines are hatched with color when you export that. Is there an option that the hatching can be removed, changed, or something like that?
Very good question and very tricky for us question, yes. So we did like so, if the polygon is closed in a CAD, so let's take one roof, for example, this here. If I go to select tool, select my polygon, and if I see attributes here closed, it's going to be filled with color. If I go no, it's not more closed, but I lose the last connection here. So if I go and repeat this, let me take the same layer. No, this polygon is not closed anymore. Okay, you see here now, and then on the ortho photo, it's also not going to be colored, so like it here is, okay? So this is a fix for this, but in future we already discussed, yes, that this would be additional parameter if you like to fill out the colors. But the first idea was if you have the closed polygon, you would also like to see the area, and then we show you the area. This was done. This was the reason why. Yeah, but okay, you know the workaround, and we will improve also this. Is it important to draw curved line? Not yet, not yet. So we plan today to give you a circle for the 3D split line, but no, it's not possible. So separate lines.
Also on to-do list, yes.
Yes, of course. There are still a lot of things. Okay, cool. I wouldn't be too long with this one. Thank you for your patience. Hopefully you enjoyed the webinar. This was the last webinar in this session before the summertime. Now we have 2 or 3 months pause with the webinar. So thank you for coming. And
thanks for the questions.
See you next time. And yeah, Mattia, feel free to finish with.
Well, if you missed the beginning, you'll get the recording, and yeah, that's it. And see you next time. Enjoy.
See you. Bye-bye.
Bye-bye.